Welcome back to Chapter 2. In this section, we will be looking at standard form of a line. So we've already seen the slope-intercept form and the point-slope form of a line. And we're going to see the standard form, then we're also going to do a little bit of a comparison between that and slope-intercept, because those are the two forms that are super useful. Point-slope form is useful, but it's mostly useful as a way to get to the slope-intercept form. So our learning target for today is I can write and graph linear equations in standard form. And so the question here is, what is standard form? So far, our forms have looked like a y equals something. Standard form, though, isn't. It's ax plus by equals c. A, b, and c are just numbers. Those are just numbers. They are integers, so we don't generally have any kind of fractions or decimals. I have seen them occasionally, but that's not true proper standard form. Generally speaking, we do want them to be integers. And also, this a value is positive. If that's not positive, we would just multiply everything by a -1 to make it positive. So a, b, and c are integers, and a is greater than 0. So how does standard form come out? Like, why would standard form be useful? Standard form is super useful in application problems sometimes. There are really two major types of applications where we would use lines. The first time is what we saw when we were looking at slope-intercept form, where we have a rate of change and a starting point. And that goes perfectly into slope-intercept form. The second way is something like this. You want to spend $150 on concert tickets. Reserve seats cost $25 each, and general admission seats cost $10 each. We want to form a linear equation to see how many different types of concert tickets we can buy. So if we were to do this in slope-intercept form, it's really not very easy to put this directly into slope-intercept form. So we're actually going to start out with standard form. For standard form, we need two variables. We need x and y. So let's have x be the number of reserved seats, and y be the number of general admission seats. So how much are we going to spend on reserved seats? We're going to spend $25 times however many we get. And then we're going to add on to that the amount we spend on general seats. That's going to be $10 times however many we get. And what we have is we have $150 to spend. This is the equation standard form. This 150 is called the constraint because that's our limiting factor. That's all that we have to spend. If we wanted to write this in slope-intercept form, start out with standard form. So we have 25x plus 10y equals 150. And now we are going to put it into slope-intercept form, we need y equals. So we would have to move the x's. Minus 25x, minus 25x. So we have 10y equals negative 25x plus 150. And then we would divide everything by 10. And so we would get y equals 25 over 10. We can divide each of those by 5. So that's going to be negative 5 halves x plus 150 divided by 10 is 15. And so what the standard form says is it gives us the equation. It says we have the $25 times the number of reserve seats plus $10 times the number of general seats equals that constraint, that $150. What the slope-intercept form gives us is if we bought 0 of the x's, 0 reserve seats, we could buy 15 general seats. That's what standard form gives us. And so in this, or slope-intercept form, in this case, slope-intercept form doesn't really give us much because that rate, that negative 5/2 x, that's for every reserve seat that we buy, we're going to lose 5/2, or we're going to lose 2.5 general admission seats. Yes, that is technically a rate, but it's not necessarily the easiest way of looking at that. So these are the two main ways that we'd write equations. And again, standard form is great when we have situations like this, where we have values of things. So let's take a look more at standard form. Let's see how do we graph standard form? Because graphing slope-intercept form is pretty straightforward. We graph the y-intercept, and then we use a slope to find our next point. With standard form, what we're going to do is we're going to find the intercepts. Now that's plural, intercepts. We're going to find the x-intercept and the y-intercept. So the x-intercept is when y equals 0. So if y equals 0 in this equation, notice this is the same equation that we just had. We're going to graph this equation. So when y equals 0, that 10y becomes 0. So we end up with 25x equals 150. Divide by 25. 150 divided by 25 is 6, so x equals 6. That tells us if we have 0 y's, we can get 6 x's. X's were the reserve seats, so we could get 6 reserve seats if we had no general seats. So that's the x-intercept, and we can find the y-intercept, which is what we find in slope-intercept form. That is when x equals 0. So the x-intercept, that would be the point 6, 0. The y-intercept will be the point 0, comma something. We make x equals 0, so that 25 times x, 25 times 0 is 0. We're left with 10y equals 150. Divide by 10, divide by 10, y equals 15. So this point would be 0, 15. We have 2 points. All it takes to graph the equation, to graph a line, is 2 points. So let's get a graph. So here's my normal graph. It goes from -8 to 8, which isn't going to really help us too much since we have 15. So let's zoom out a little bit, and we get this one. So we can graph our points. We have 6, 0. So that's going to be right there. 0, 15 is going to be up there. And then we connect the dots using a straight line, which is easier said than done sometimes. Let's see how I can. That one's not too bad. Arrows both ways. And so we graphed it in standard form by just finding intercepts. Now, I showed a lot of work to find my intercepts. A lot of times, especially like if I'm doing it on the board, when y equals 0, I just use my hand. I cover up that 10y. So we have 25x equals 150, divide by 25x equals 6. Then do the same thing for the other one. Let's do another one. We have 3x minus 2y equals 9. So we can find the x-intercept. That's when y equals 0. So we're going to have 3x equals 9. Divide by 3. So x equals 3. And then we can have the y-intercept. Oh, so this would be the point 3, 0. Then we can have the y-intercept. The y-intercept is when x equals 0, so we'll have -2y equals 9. divide by -2, and so y equals -9/2, which is not the easiest thing to graph. Sometimes a mixed number is going to be easier. -9/2 is going to be -4.5. So that's going to be the point 0, comma, -4.5. All right, so we can graph our 2 points. We have 3, 0 is on this one. Then -4.5. I know sometimes people have trouble graphing with fractions. It's just halfway in between -4 and -5. So we have our 2 points. We can connect the dots. And put our arrows. So that's that one. We find our 2 intercepts, connect the dots, and there we go. So go ahead and try one. Try this one. We have 4x plus 5y equals 10. Find the intercepts, graph it. So go ahead, pause this, and then push play again when you're ready to come back. How did you do? You think you did it? All right, well, let's take a look. I'm going to use the same graph, just switching to blue. So we can make y equal to 0. So we'll have 4x equals 10, divide by 4. So x equals 5/2, because we can divide each of those by 2, which is 2.5. So that's going to be 2.5, comma, 0, which will be 1, 2.5, comma, 0. And then make x equal to 0. So we'll have 5y equals 10, divide by 5. So y equals 2. So you have the point 0, comma, 2, which will be right up there. Connect the dots. Using a roughly straight line. Oh, apparently I can draw with my finger. I'm touching it and it's drawing. I wasn't able to draw with my finger the other day. So we have that line. Is that what you got for that one? If not, do you see where you made a mistake? All right, so more graphing in standard form. Question is, what if that a value, remember that we have ax plus by equals 0. What if a equals 0 and we end up with like -2y equals 8? Well, we could divide by -2 to get y equals -4. Well, what does that look like? Well, let's graph. Well, we know that when x equals 0, y is going to equal -4. So we're going to put that point there. What about when x equals 1? What will y equal? Well, there's no x in the equation, so y will still equal -4. How about when x equals 2? Well, y equals -4. It does not matter what x will equal. Y will always equal -4 in this equation. And so that gives us a horizontal line. And that happens when you have y equals a number with no x's in it. And that doesn't matter if it's standard form or slope-intercept form or anything. Like technically in slope-intercept form, this would have a slope of 0, which is a horizontal line. All right, so that's when a equals 0. What about if b equals 0? We'd have some number times x equals something because there's no y. Well, we can divide again to get x by itself. And so we get x equals 2. Well, so when y equals 0, x equals 2. When y equals 1, x still equals 2. Y equals 2, x equals 2. In fact, it does not matter what y equals, x will always equal 2. And so when we have x equals a number, we get a vertical line. So when there's no y in the equation, we get a vertical line. Notice this actually can't be written in slope-intercept form because the slope is undefined. We have rise but no run. And so, like, slope-intercept form is y equals something. This doesn't have a y to be equal to. So a vertical line is actually the only line that cannot be written in slope-intercept form. It can, however, be written in standard form. It's just x equals a number, like x equals 2. And so when we are missing one of our variables, we get either horizontal or vertical lines. Now, the trick is remembering which it is, because you see, like, y equals a number and y is our up and down axis. And so we always think like, oh, that should be up and down. No, that's a horizontal line because that y value will be the same and it does not matter what x is. And then same thing for the x values. All right, so let's do another application problem. This is kind of like what we did in the very beginning. So in this problem, I don't have actual places where it's going to pause, but I'm going to ask you to pause really quick so that you can try each step as we're doing this. So the problem here is Tamira is making trail mix. She has $40 to spend on a mixture of almonds and cashews and wants about the same amount of almonds as cashews. How can she determine how many pounds of each kind of nut to buy? So, what kind of information do we have here? Right now, we have $40, and we also know that she's going to be buying almonds and cashews. But, we don't know how much. That's going to be our variable. But what else are we missing here that would be really nice to know? How about how much each of them costs per pound? That would be nice to know. Well, a lot of times in problems like this, you have to look at more than just the words. Along with this problem, there's this picture. Now, I know that sometimes in math books you have a picture and it doesn't really make any difference to the problem, but sometimes they do, especially here, because this picture tells us the prices per pound. So we're going to write an equation. Let's say the almonds are going to be the x's and the cashews are going to be the y's. So the amount of almonds is x, the amount of cashews is y. Go ahead, see if you can write the equation to this problem. The pause isn't going to come up, but if you need to pause, you can always pause. Do you have it yet? Last chance to pause if you need it. All right, well, let's take a look. So we have $8 times the amount of almonds. So that's going to be 8x plus $10 times the amount of cashews, 10y, and that's going to have to equal $40. Now we will get to inequalities with this too, because could she spend less than $40? She could, but not in this problem. In this problem, she is going to spend $40. So we have 8x plus 10y equals 40. Okay, so now we're going to graph it. So now if I have this graph here, are we going to have, like, we have to think of what we're using. We have the amounts of almonds and the amounts of cashews. Am I going to buy negative almonds? No, you can't buy negative almonds. Same thing with negative cashews. So we don't need to have the entire graph. For something like this, We only are really concerned about the positive part. So let's get the positive part. What that does is it allows us to be a lot more accurate. So we have this graph. Now we need to graph our equation. So we want to find our intercepts and then graph them and then draw a line. So take a minute, find the intercepts, and graph the equation. Again, you can pause me if you need that extra little bit of time. This is a chance where you get to try it without any kind of pressure. All right, are you ready? Last chance to pause me. All right, so let's say y equals 0. So we're going to have 8x equals 40. We can divide by 8 to get x equals 5. So that's the point 5, comma 0. And what that means is that if she bought 0 pounds of cashews, she could buy 5 pounds of almonds. So we're going to go to 5 comma 0, put our point. And then if x equals 0, if she bought 0 almonds, we'd have 10y equals 40, divide by 10, and so y equals 4, which is the point 0 comma 4. So if she bought 0 pounds of almonds, she could buy 4 pounds of cashews. Then we can draw the line. Now with something like this, I recommend some sort of a straight edge, because the more accurate your line is, the better. Now, I can't use a straight edge because it's touching my touch screen, and that's becoming problematic. So I'm going to do my best. That actually came out to be fairly straight. So we have our graph. Now we want to know how many pounds of each can she buy. She wants them to be about the same. So about the same is going to be kind of in the middle. So we have a point like right here where she has 2 pounds of cashews, and it looks like 2.6-ish or so pounds of almonds. We could have the point right here, which looks like she has 2 pounds of almonds and about 2.5 pounds of cashews. And so we're just taking the points off. Like any point along this line will be an amount that she can buy. Now you don't have to buy full pound amounts, notice, like we have 2.6 and 2. And that is going to be an estimate, by the way. We can only tell so much from the graph. If we really want to, find out, to check to see if that's an actual value, we would plug those two numbers into x and y and see if it actually does come out to 40 or not. So that, though, is a type of application problem that you'll see. It's a very standard type. A lot of times you're buying something or you're getting money for something, but there's usually two different things. They each are set up exactly like that, and it's going to equal a total amount. So this would be the standard form of the equation. Make sure that you are working on your assignment. I will see you in class, but until then, keep working problems, keep asking questions, and as always, happy mathing.